Hello everyone, welcome to my representation about the topic insulator transformer oil. I am Phạm Hoàng Đức Thượng. The student ID is 23151185. So the content will include 5 parts. 1. Overview of insulator. Part 2. Transformer oil. Part 3. Application. Part 4. Development part. And Part 5. Conclusion. Part 1. Overview. Insulator. So, what is insulator? Insulator is a material in which electric current does not flow freely. The atoms of the insulator have tightly bound electrons which cannot readily move. Other materials, semiconductors and conductors, conduct electric current more easily. The property that distinguishes of insulator is resistivity. Insulator have higher resistivity than semiconductor and conductors. Properties. It has high resistivity from 10 to the power of 8 to 10 to the power of 18 ohm centimeter. All insulator become electrically conductive when a sufficient large voltage is applied that the electric field tears electrons away from the atoms. This is known as the electrically breakdown, and the voltage at which it occurs is called the breakdown voltage of an insulator. And the insulator has high mechanical and chemical strength durability. This is the formula of resistance. From this formula, we can infer the resistivity, where R is the wire resistance, A is the cross-sectional area, L is the wire length, and P is the resistivity. 3. Classifier. First is the classification based on physical state. A. Solid. Include porcelain, mica resin, wood, glass, rubber. B. Liquid with mineral oil, liquid helium, liquid argon, benzene, and silicone oil. C. Gas. Include air, carbon dioxide, sulfur, hexylene fluoride, and carbon monoxide, nitrogen, and hydrogen. The next is the classification based on material origin. With the natural origin, include mica resin, oil wood, natural rubber, beeswax, amber, cotton. B. Synthetic or artifact. We got PVC, also as known as polyvinyl chloride, fiberglass, and Teflon. These are some images of the insulator. And finally is the classification based on heat resistance. So we got the insulation class A with the maximum temperature allowed is 105 degrees Celsius. The allowable temperature rise at full load is 55 degrees Celsius, and its typical material is cotton, natural silk, synthetic zinc, and breast band, and so on. We got the type B, type E, F, and H. So let's come to part 2. One concept. The transformer oil or insulating oil is an oil that is stable at high temperature and has excellent electrical insulating properties. It is used in oil field with transformer, some type of high voltage capacitor, fluorescent lamp pellets, and some type of high voltage switches and circuit breakers. Its function is to insulate, suppress corona discharge, and arcing, and serve as a coolant. Most often, the transformer oil is based on mineral oil, but alternative formulation with different engineering and environmental properties are growing in popularity, such as silicone oil, naphthalene oil, and ester oil. These are some examples. 2. Function and properties. A. High dielectric strength. So this is the chart so that the typical breakdown values using the 877 decimeters, and this is the oil type. The number comes between 40 kilovolts to 56 kilovolts. 2. B. Good thermal conductivity. You can see the transformer oil's thermal conductivity is 0.3714 watt per millikelvin, and the viscosity at 29 degrees Celsius is 12.4 millipascal. C. The high purity and freedom, free from conductive contaminant. So those are the characteristics. All those characteristics and specification has been met the decimeter of ISO and IEC. Those stuff have to ensure the oil remain non-conductive under high voltage and prevent the current leakage and maintains insulation performance. D. The chemical stability and low oxidation rate. This is the acid value, 0.142. The lower the acid value, the transformer oil has the higher chemical stability, and the percentage of sludge is 0.91%. The lower of the sludge percentage make the higher oxidation sustainability, and this help resist chemical breakdown under the heat and exposure to air, and prolong the oil life, reduce the need of frequent replacement or maintenance. E. The moisture resistant. Using the oil moisture meter TOR1. This have the transformer oil absorb and insulate moisture to prevent it from reaching paper insulation and other internal parts, and maintains the integrity of insulation and prevents the electric failure. F. Non-corrosive to metals and insulation materials. It doesn't react with metal like copper or insulation component inside the transformer. Some sinful compounds in oil can react with copper to form the corrosive copper sulfide, which is dangerous to transformers, preventing the damage to internal components and ensures the long-term reliability. So, summary, the transformer oils serve multiple essential roles, including the insulation, cooling, and moisture protection, making it a critical element in ensuring the safe and efficient operator of power transformers. 3. The production. Let's watch this video.
X-Men Phobos đang ngông đích thực nói được làm được. Hứa hứa sẽ đến đúng giờ.
On 11th and 12th June 2016, a CMM47 and a BV vacuum section were commissioned at one of Kuwait transformer substations in El Kuwait City. Commissioning of several units at the same time is a frequent occurrence in power industry and is very efficient. In this case, several important problems are solved. The CMM47 vacuumizes transformers and purifies transformer oil, removing particulate matter, water, and gas. This unit can be used to heat a transformer, degas oil, or vacuumize the transformer. To improve safety of electrical insulation oil treatment, it is recommended to use the TSS system. This system disconnects the CMM from the transformer in certain situations, such as oil leaks, oil level exceeding limits, false triggering of the Buchholz relay, etc. The BV1000 vacuum section evacuates air, non-aggressive gases, vapor and gas-vapor mix from airtight vacuum system at the rate of 1000 cubic meters per hour. This unit creates vacuum in transformer tanks and dries electrical equipment. The important feature of the unit is its ability to be used in combination with transformer oil degassers. It should be noted that all testing and commissioning operation in Elk Weight were completed in difficult conditions. Ambient temperature approached plus 50 degrees centigrade. However, Globcore equipment displayed outstanding performance.
So that is the end of part 2. Part 3, the application. The transformer oil is used to insulate high voltage electrical infrastructure such as transformers, capacitors, switches, and circuit breaker. So you see the PDV text is breakdown voltage, and the number is rise can reach almost 70 kilovoltage. B. Transformer oils are designed to operate effectively at very high temperature, cooling, insulating, and stopping corona discharges and arcing. So look at this picture. When our transformer operates, the electrical energy will pass through the primary and secondary windings. That is those two. And the magnetic flux will flow in the core. This causes the losses, which is generate heat inside the transformer. 2. The inside of the transformer tank is filled with transformer oil. This is the blue liquid. This oil surrounds the core, and windings absorb the heat produced. As the oil near the winding gets hot, it becomes less dense and naturally rising upward. This process is called natural convection, and no pump was needed. The hot oil will move into the radiator tubes on the side of the transformer. These tubes right here increase the surface area of heat dissipation. The heat from the oil will transfer to the surrounding air through the radiator walls. Then as the oil loses heat, it cools down and becomes denser. Then it sinks to the bottom of the radiator tubes. This direction right here. And then it will flow back into the bottom of the transformer tank where it absorbs more heat again. Right here. This is natural convection cycle will keep repeating, continuously remove heat and maintaining the transformer temperature within safe limits. Part 4, the development part. A. That is the eco-friendly and biodegradable oil. So the trend is to shift from the mineral base to natural ester base or synthetic ester oil. This method advantages is the biodegradable and less toxic to the environment. It has the higher fire point and better moisture tolerance and the electric performance. The use case of this method is widely adopted in urban, renewable, and eco-sensitive environments. B. Improve the oxidation stability and longer life. This is an innovation development of oil which enhance the antioxidant additive or inherently stable molecule structure with the goals to reduce oil aging and minimize maintenance, especially in the sealed or hermetic transformer. C. Recyclable and regenerable oils. This method focuses in improved oil refining and regeneration technology to recover and reduce aged oil and reduce the oil disposal waste. That makes the lower environmental impact and cost. D. High performance oil for HVDC and compact equipment. The need is to development of oil with better dielectric and thermal properties to HVDC transformer, offshore wind and solar grid transformer, and compact high load density application. And finally is smart monitoring and predictive maintenance integration. So the final part is the conclusion. The transformer oil plays a vital role in ensuring the safe, stable, and long-lasting operation of a transformer, with its primary function of insulation, cooling, and protection against moisture and corrosion. The oil helps extend the lifespan of the transformer and prevents serious technical failures. In the context of increasingly complex power systems with higher demand for performance and environmental safety, the selection and maintenance of transformer oil have become more critical than ever. Far beyond being just a supporting material, transformer oil serves as an invisible shield that protects the very heart of the power system. What I say is about the transformer. So that is the end of my representation. Thank you everyone for listening.